About 65 miles southeast of West Virginia's Kanawha Valley sits the Bluestone Dam. Bluestone is the largest concrete gravity dam in southern West Virginia. It stretches nearly a half-mile across the New River near the town of Hinton. The dam, which stands 165 feet above the riverbed, was built in the 1940s by the U.S. Army Corps of Engineers. The project created the 11-mile-long Bluestone Lake, the third largest lake in the state of West Virginia. While the lake provides a great source of recreation, its main purpose is to reduce flooding along the New, Kanawha, and Ohio rivers. Bluestone Dam operates as part of a system which influences some of the impacts from rain and snowmelt on a little more than half of the Kanawha Valley. The Corps estimates that since 1947, Bluestone Dam has prevented over $2 billion in flood damages, which is equivalent to over $5 billion in flood damages at a 2012 price level. The Corps adjusts the amount of water behind the dam based on the season to provide additional flood control storage in the winter. When heavy rains fall, engineers operate Bluestone to hold water back to reduce the flooding downstream. The Corps controls the release of water through the dam's outlet works. Normally, water flows through sluice gates in the lower portion of the spillway. During high pool flood events, water can be released through crest gates, which slide up to release water over the spillway. If floodwater ever threatened to overtop the dam, the Corps would also release water through the penstocks. Bluestone was built as a concrete gravity dam by constructing a series of concrete sections called monoliths. This type of dam relies on the weight of its concrete to remain stable. The more water in the pool, the greater the force on the dam. Today, the Corps of Engineers plans for storms far more severe than were thought possible when the dam was built. Engineers now know that if the water level nears the record pool, the water pressure on the lake side of the dam could force the dam to slide on the rock on which it's built, and spillway flow and penstock flow could result in erosion or scour to the downstream rock that helps to keep the monolith stable. To reduce risk, the Corps began a series of construction projects to anchor the dam, minimize scour, and increase the amount of water the dam can hold during flood events. A massive slab of concrete, called a thrust block, was placed against the dam's downstream edge in the area originally designed for a hydroelectric powerhouse to act as a giant doorstop. The penstocks pass from the reservoir through the dam and thrust block to the downstream side. A new fishing pier downstream below the dam was constructed to help compensate for any disruption to recreation because of construction. The pier makes the New River, a popular warm water fishery in West Virginia, handicap accessible for fishermen for years to come. But the key work for increasing stability during flood events and bringing this concrete dam up to modern-day design standards is the addition of hundreds of high-strength anchors. A temporary construction platform and walkway allows drilling equipment to set up on the downstream face of the dam and begin the anchoring process. Mike McCrae is the Chief of Engineering Geology and Project Geologist for Bluestone Dam. He explains the Corps' anchoring process.
Each monolith is designed to be stable under its own weight. But what we learned when we analyzed Bluestone for current criteria and using modern rock strengths was the factor of safety for sliding did not meet our criteria. So what we decided to do was to use multi-strand, high-strength anchors to resist the load of the reservoir. This is the recess area that's been patched after completion. We have one anchoring system that's at a 45-degree angle on the face of the dam, and on the top of the dam we have a 8-degree anchor coming straight down. The two anchor systems cross each other at a depth of about 170 feet, and it's critical that neither anchor intercept the other, or we'd lose that load. First, we drill a pilot hole. We have to drill a very precise boring to start the anchoring program due to the fact that the anchors are so closely spaced. And after that hole is drilled, we then survey it. If it meets our drill tolerance and we accept that hole, this recess is then reamed out, which is about 38 to 42 inches in diameter. The rest of the boring is reamed out to a final diameter of 15 inches. This gives us room to put in our corrosion protection and our multi-strand anchor, which is made up of cables or what we call strand. This is one strand, so when we talk about a 61 strand anchor, you're talking about 61 of these cables. Each one of these has a design load of 35,000 pounds. The grout is pumped into the bond zone. This is allowed to set for 5 to 7 days, and then the anchor is stressed. And as we stress it, we're pulling this strand through the grease sheath like a rubber band and test the anchor to make sure everything is proper in the bond zone, and then we lock it off at over 2.5 million pounds. That's slightly more than we actually need, but strand or steel relaxes over time.
With the anchoring well underway and hundreds of anchors expected to be installed, the Bluestone project next turns to the discharge area in front of the thrust block and extended penstocks. Heavy construction equipment excavates the area to create a concrete stilling basin for the new auxiliary spillway. Concrete divider walls between the penstock openings combine with right and left training walls to manage the flow of water if the penstocks are ever open. Concrete baffles dissipate the energy from the water. The work at Bluestone Dam also increases the discharge capability in the main spillway beyond what originally was anticipated when the dam was built. Modifications and improvements allow more water to be discharged through the dam during extreme events, while also preserving the bedrock in front of the dam from scour. The improvements at Bluestone Dam have involved many years of work and countless hours of manpower. But the payoff is a massive structure that remains as impressive today as when it first grew in those West Virginia hills. Residents can be assured that the work on Bluestone brings it up to modern-day standards. It continues the Corps of Engineers' mission of protecting human life, property, and the environment for generations to come.